Hey, Algebra 2. Today we're going to spend our second day on modeling riverbeds with polynomials. You already got this page in the last class set, but we're going to look at it again. We read it before, but the Environmental Protection Agency is studying the flow of a river in order to establish flood zones. If you remember in the last lesson, we drew a graph through this. And then we drew triangles, which are better than these, and trapezoids, so we could work on approximating the area. And I'm pretty sure that is where we left off. Okay, we knew where we were missing data at depths of 40 and 80 feet. And we knew that once we find a polynomial function that represents this graph, then we could use that polynomial function to evaluate at 40 and 80 feet. We talked about the lowest degree polynomial that could be used to model this data. We have 1, 2, 3, 4, 5 points. So we would look for a 4th degree polynomial. And then we knew the constraints that our polynomial must meet. The constraints were at 0, and 120, and then at 60, looks like it's our maximum. So, and that's where we left it. So today we're going to actually move on. So find a polynomial P that fits the given data points. Okay, we're going to do that with our graphing calculator. So go ahead and get your graphing calculator out and practice along with me. We'll move number 2 to the next page. But if you hit the Stat button and edit, you're going to fill in your data in list 1 and list 2. List 1 is going to be all the x's, and list 2 will be all of the y's. So we're at Stat, Edit. I'm going to type them in, so I'm going to push pause. You go ahead and type them in too. There we go. Now we're going to do some regression. So let me go to the next page. Okay, if we go back to our Stat button and then Calc, we said that we have 5 data points, so we're going to do I said cubic in the last one, didn't I? I'm sorry. It's a 4th, no, I said 4th degree. So we need to find the 4th degree regression, which is the quartic regression. So go ahead and do that and we'll come up with a polynomial. Okay, that's what I got for the polynomial, and the r² value was 1, so it fits pretty awesome. Okay, that's a good r² value. It's as good as it gets, actually. So remember this, and we are going to use this polynomial to evaluate at x equals 40 and x equals 80. But I need a new slide. Okay, this should actually be p of x. Right there. I made a mistake and I can't erase it now. So we are going to evaluate our polynomial at 40 and 80 to find the points that are missing. So I'm going to get my calculator and give it a workout, and I will be right back. Okay, evaluated at 40 is negative 17, and evaluated at 80 was negative 21. Cool? I think that was the answer to part 2. Sorry, I forgot to get part 2 back on the screen. But let's move on to part 3. Estimate the area of the cross-section. So we know those missing points now. This was at 40, we got negative 17. And at 80, we came up with negative 21, which will be somewhere in the middle. Cool. So to estimate the area, if you remember last lesson, we drew our curve That was pretty good. And we came up with 2 triangles and 4 trapezoids. So to estimate the area of the cross section, we're actually going to do, let's do this. We're going to number them 1, 2, 3, 4, 5, 6. We need the area of a triangle is 1/2 base times height, and the area of a trapezoid is 1/2 base 1 plus base 2 times height. So we have all of these shapes here. The first one's a triangle. I'm going to say the base is 20 because we're going to take that as the base, and the height, make it a right triangle, and the height is going to be also 20. 1/2 times 20 times 20. We don't take into account negatives because we can't have a negative height. And we're at 200. Area of the second one, I'm just going to do the second one and then you can work through the others. We have a trapezoid, which I'm actually going to, that trapezoid sort of needs to sit on its side. There we go. So I have base 1, base 2, and the height. Let me redo that for you. It doesn't matter, but I've got 1 base, 2 bases, and the height. So I have 4 trapezoids that I need to find the area of. So for this first one, I have 1/2. Base 1 is 17. Base 2 is 21. It doesn't matter what order because you're adding, times your height, which is 40 minus 20, which is 20. Let me calculate that. 0.5 times the sum of 17 plus 21 times 20, and I get 380. Okay, go ahead and do the area of the next 3 trapezoids and the last triangle, and then we will compare our answers. Okay, I didn't get very far. I found a mistake. For area of 2, it's actually 20 and 17, so this should be a 20, which if you do the math, that makes this 370. Didn't want to move on without catching my mistake. So now I'm going to go ahead and work, and we can come back at the end and check our answers. Okay, got all the answers in there. Double checked my work. I think I'm good. So go ahead and push pause and see if you got the same answers that I did, and then we'll move on. Suppose that the river flow speed was measured to be an average speed of 176 feet per minute at the cross section. What is the volumetric flow of the water? So the volume of the water per minute. We just found that our volume, or our area, our cross-sectional area is given, and we are multiplying it by 176 feet per minute. So that is going to give us, just multiply straight across, 344,960 feet cubed per minute. Convert the flow to gallons per minute. 1 cubic foot equals 7.48052 gallons. So take the answer that we just got, and 1 foot equals 7.40852 gallons. Cubic foot. There we go. Nice work. And that gives us a whopping 2,580,000, forgot the 0, 480 gallons per minute. That is a lot of water. If I think about a gallon of milk, and 2 million of them per minute. That's a lot of water. All right, good job today. We'll see you tomorrow.